Good morning, all of you. I would like to welcome you all on behalf of Edureka to this very informative session today. I am Atita Arora, and I have been working in solar, Lucene, and related technologies. So, been here for about 9 years now, and I carry experience of developing applications in social media, news, and healthcare domains. So I would be taking you through a quick introduction on how we can build, better applications with Apache Solr. So let me just quickly go about taking up what exactly and what all we would be covering today in the session today. So at the end of this module, you would be able to understand that why do we need search engines for the enterprise grade application. So why exactly is search needed is what we would be talking about. There are few objectives and a few challenges of the search engine which we would be discussing. We would be discussing about indexing and searching and why exactly would you need them, why exactly anyone would need them. Then we would be talking about indexing and searching. How is it handled by Lucene? Now, for folks who are a little confused about that, the webinar was supposed to be talking about Apache Solr, but there is something new which we are talking about here. So Apache Solr is nothing but nicely groomed up Lucene, which is again the Apache library, which is the search library basically. So Apache Solr is built on top of this Lucene. So it handles every bit of what goes inside Solr. So indexing, searching, analyzing the data and stuff. So I would be taking you through that step by step. So how many of us have really used this website, Flipkart.com? Let's see, how many are tech freaks here? Okay, all of us, yeah. Actually, indeed, all of us must have used this website. And I'm sure everyone must have seen this search field out here. And in this field, we really exploit this field. We type in whatever we want, and you get suggestions. You get what is the most popular product in the category of the products you're looking for. So over here, if I say that if we do not have this search text box available on this window, how would this website look like to you? Any guesses? How would this look like to you? How about using any e-commerce website without the search text field? Would it be easy? Would it be user-friendly? Yeah, bit tedious. Yeah, right, Nitin. It actually makes no sense. So the user friendliness and oh yes, Naresh gave a very nice example: car without steering. In fact, this text field acts as a steering, that which direction or which kind of product or what kind of category of product are you looking for. So certainly, yeah, right. So I mean, you guys are way more bright than I actually thought. So, right, I mean, if we are supposed to be using any e-commerce website and we do not have this text field over here, imagine, going through, a flat file search. You would have to go through each document one by one and evaluating that, is this what I need? No. Close this down, open another one. Is this what I need? No, not really. Close this down, another one. So it would be like a flat searching for anyone. So all these, fancy features of, putting up nice photographs and providing you with offers and stuff is going to be of no use if you cannot make a product searchable. So these are a few of the things which make it so essential to have this field on your website. Along with that, on the left-hand side, if you see that we have provided more flexibility to the search, that the products which are rendered on the basis of the text which you're searching, they are bifurcated on the basis of the price range they belong to, the brand they belong to, the operating system they work on, and on the right hand side you have few suggested products that people who were looking for the kind of product you are looking for also considered looking these products as well. So this comes handy. I mean, if I'm very new to the e-commerce website, I say I'm looking for a quad-core mobile phone, and I have few suggestions out here with KitKat OS, with it's a Sony mobile phone, or is there any screen specification I want to provide along with my search text. So this is providing me with the auto suggestions as well. Along with that, it also consists of what are the popular category of products which fall under the same category or the same product bracket of the same product which we are looking for currently. So this makes it so flexible for anyone to look for a price or brand or any particular feature you are typically considering when searching for any particular product. So this could be, I mean, this is the mobile example which we have taken. It could be anything like it could be a dress, or it could be hardware essentials, a hard drive, or headphones and stuff. So you can easily look for the product which you're looking for on the basis of price, on the basis of brands. So this is all configurable. So this is all controlled by the XMLs and the configurations which come handy with Solr. So I mean, if you look here, I mean the first text field which we have highlighted is the text-based searching. So it aids to the text we can provide for searching. The second one which we have highlighted is one of the powerful feature which comes handy with Solr is like filtering the result set on the basis of, say, price or brand, operating system, or say could be anything. So it could be features as well. So third one is we have highlighted one picture, which is not really a picture, but everything goes inside in the form of a document. So when you click on this particular product, you are redirected to a screen which consists of all the information. Right now we're just summing up all the information like the name, the star rating of this product, say which category it belongs to in mobile category, then the actual price and the sale price which is offered by the site, and there are few important features which we feel distinguish this product from the other products. So this is how we are representing this product as of now. However, if you click on this product, you are redirected to the document which consists of all the information regarding this particular product. So this is how essentially a search engine works. So it makes it really easy for the user to trace or find a particular product which they are looking for. Excuse me. So over here, if we talk about that, we're talking about the search engine or the search capabilities of an application. What exactly should it all have? Like if you need to have a storage engine to search records or documents on the basis of text or the free text keywords, so it should support following features. So first of all, it should give you the optimized results for faster text searches. So along with that, it should also provide you with the feature that there could be a case in which few of the products may not have the same fields as the fields in the other product, right? So let me just quickly take an example like talking about Schema. And if you're talking about the mobile phones here, so suggest me guys, we have name of the mobile phone, we have a brand of the mobile phone, we have say price range of the mobile phone. Can you guys guess any more Schema fields? A mobile phone OS, yes. Processor, yes. Yes, guys. Wow. Okay, processor and yeah, screen resolution, right? And camera, yes. So RAM, yes. Color, yes. Right. So you can have a hell lot of features these days. I mean, so we're not needing a system which is going to limit us with that every product should have these fields. I mean, every product may not may or may not have these, field values. Like a normal, a phone might not have a camera. So I could say that, no, there is no camera, or I might not provide any information. So if I'm talking about the iPhone, I say that, yes, it has the camera and it has got, say, 8 MP resolution. And on the other hand, I have some very, very, basic mobile phone which do not have any camera. So either I can say that not available, or I can say I should have a freedom that I can add or not add any values pertaining to any field. So it should be flexible enough to accommodate these kind of features. So if I'm pushing any document inside the repository, my my document. When I'm saying document, it means that I'm talking about one Lucene document. So guys, this is one similarity, or I can say, I just want to create a little similarity for you guys to understand how things really work with Lucene. So I'm sure every one of us have worked on some RDBMS, some database of any variant. I'm sure most of us have worked on some sort of DB. Yes? No? Maybe? Right. Okay. Nitin says yes. Okay. All right. All right. Okay. So I hope everyone understands that whatever goes inside a database, goes inside in a form of a record. Right? Everyone is aware of that as well? So everything goes inside a database in the form of a record. In the similar manner, in Lucene, everything goes inside in the form of a document. Right? So likewise, you can have a small similarity that in a database, we have something like column, and we define that what type of column it is going to be, what are the limitations, if it is going to be, say, primary key or not. So this is how we define the schema in our database table. In the similar manner, when we talk about Lucene or Solr for that matter, we have the XMLs. So they're going to control that what all, this basically defines that a record is going to consist of, say, n columns, and what are going to be their type. In the similar manner, we have Lucene, and everything goes inside in the form of a document, and every document is going to have a field, and the fields are going to have the properties. In the similar manner, we have the column properties in our database. Is that clear, guys? I'm sure this is going to help to understand how things really work. So do not get confused when I say, document a lot many times, because what I'm essentially talking about is a record. So everything in database which was a record is, set or called a document in Lucene or Solr. Okay? So it should support sorting of documents as well, because obviously we would be wanting to look and sort the documents on the basis of how user would want to. Along with that, it should be web scalable, which means that it should be optimized for reads, because the data which is on the website is read more number of times. So I'm not sure about the figure, but the Flipkart, Amazon, these sites, I'm sure are visited by hell lot of people every day. So your hardware, your software, your application should be robust enough to handle so many number of reads. Along with that, it should be document oriented as well, the search engine. Why? Because everything which is displayed to the user is displayed in the form of a document. So everything comes handy when we have a document or say a record based system herein, right? So everyone is aligned to these things, that we should have a system which supports all of these features. Any other feature you guys feel a search engine should have apart from the features which we have listed here? Yes, no, maybe? No? Okay, so I guess we're good enough. So this is one of the examples from the Cleartrip spatial search. So spatial search, if I mean you guys are not aware of, just to reiterate. So we are going to perform a search on, say, a map, and every document, essentially, which I mean is what I mean is a record. So every record is going to consist of a lat long field, and we're going to represent that particular lat long field on the map. So we can also search on the basis of the position or the location of that particular document. So if you look here, this is the spatial search UI which is provided by Cleartrip. And if you look here, there are a lot of pointers over here, and it is basically representing all these hotels out here on the map. So if you look for a particular hotel, it is going to tell you that what is the landmark, or how far is this hotel from the place you are in, what is the star rating, what is the location, what is the price range per night rate of this hotel. So this is how the spatial search looks like. So this is the add-on feature which came handy with Solr after Solr 4. Okay. Have you guys seen this UI before? The spatial search UI? Have you guys ever needed things to be displayed onto the maps? Does these pointer help? Yeah? Okay. Cool. So, okay. All right. So, just to give you a brief intro about Lucene first, because Solr is built on top of Lucene. So I'm not sure if you guys are not aware of this guy here. Anyone who can relate to this guy with something else other than Lucene? The duck cutting? Yeah, Hadoop. Okay, all right. Oh, okay, all right. Wow. What an overwhelming response. Okay, everyone is aware of who this guy is. Great. So, okay, so this guy is indeed the creator of Hadoop as well. So, I mean, he created Lucene way back, I think, in 2004, and he named Lucene as Lucene after his wife's name. So, Lucene is the very, very powerful Java search library that lets you easily add or incorporating the search capability of on the textual search on your application. So you can add the information retrieval and the text searching on your application using this library. So you can be rest assured about how robust this library is going to be, that this is used by LinkedIn, Twitter, I guess Amazon as well, and there are many more. I mean, when you get this presentation, I'm sure, make sure that you click on this link, and you will see that there's so many, robust names which are actually using Lucene, because it is highly scalable and it is high performing indexing API. So it lets you create the powerful and accurate and efficient search algorithm on the basis of your needs. And again, it is cross-platform as well, and it is open source, so you're not supposed to be paying anything against the licensing cost. It is 100% pure Java, so that vouches for why it is supported on most of the platforms. In fact, every platform for that matter. So implementation is also available in other programming languages as well, which are index capable. So how does that really goes about? I mean, we have been talking about, okay, all right. So you guys know a lot of things. I mean, I'm pretty impressed with most of you folks. I mean, great. So we have been talking about indexing and searching quite a lot, because these are the two, say, essential features which should be there when you're talking about a search engine. So how does indexing really works about? So like look here, I mean we have taken example of 3 documents here. So we have the first document which consists of the text I like Edureka courses, and the document 2, say D2 is the document ID. It says that Edureka teaches big data courses. The third document D3 is saying that Edureka helps learn new technologies easily. Now if you look here, we have this created out of the information which was provided. So if you submit these 3 documents for indexing, we are going to have this type of matrix. So this matrix is nothing but a inverted index matrix. So we're going to talk about it in a little while. So over here, if you see, we have split all the documents in the form of key terms. So if you look here, we have picked Edureka and courses from the first document. Then we picked out Edureka teaches big data from the and the courses from the second document, and essentially the similar terms from the third document as well. So if you look here, we have ignored few terms here like I and like and new, easily. These things we have ignored. So we would be discussing why we have ignored that as well. So we are essentially storing the crux of all the documents here. And we are maintaining a matrix in the format that we are going to maintain something like, if you know, we are storing all the terms here, key terms. Edureka is there in document D1, D2 and D3. Courses, the word as a key term is there in D1 and in D2 as well. Along with that, when we spoke about the third term teaches, it is there in document 2 only. Similarly, big data and helps, big and data was there in document 2. However, helps was there in document 3 only. So this is the kind of index which Lucene builds up at its end. So whenever somebody is looking for Edureka, for that matter, it is going to quickly look into that what all documents consist of this word. So it is going to go through, not going to go through all the documents. I mean, it is not going to go through like the flat searching mode. It is not going to, you know, go through the entire content of each document. It is going to simply refer to this matrix, this table only, and it is going to quickly see that this term was there in which all documents. So this is something very, very easy to look up. I mean, you guys can see that. I mean, the difference in parsing through all the documents or, you know, quickly referring to this matrix. Which one is going to be easy in your view? Obviously, the matrix one. Yeah? Yeah, right. So this matrix is something which Lucene looks for when it is looking for searching. So during indexing process, it is actually analyzing. It is going to break or strip all the content which is you know, decided on the basis of algorithms which you are using. So it is going to discard common, you know, English words like I, like, new, easily. So it has ignored these words. It has not indexed these words. So this is on the basis of the algorithm on which we were analyzing or indexing this data. So we're going to quickly talk about that as well. So let us not confuse you guys with introducing too many terms on each slide. So we have spoken about the document to be consisted of number of fields. So the number of fields is pretty flexible in case of Lucene. So say, unlike the RDBMS, the schema is not very rigid. So if you're trying to push any data in a table in RDBMS, which would not consist of a particular field value, so it is not going to you know, successfully push the data inside that table. However, the case is not same in case of Lucene. So if at all you have that field therein, it is going to store that field's value. If you do not push any value for that particular field, it is simply going to consider that this document do not consist of this field. So in this similar manner, we have a document which is a set of fields, and it goes inside the system which consists of the analyzer. So analyzer, as the word suggests, is going to analyze the content. So the analyzer is going to consist of the process wherein all the data is basically parsed, and on the basis of the algorithm, you have a few analyzers which come handy with the Lucene library itself. However, if you want, you can build something similar to what, as per your choice. So in our course, in this course, which we're going to start soon, the Apache Solr course, so we basically talk about the code as well. So we're going to talk about how you can use the analyzers which come handy with Solr. However, if you want, you can also build up your own analyzer. So the analyzer is basically the process which is going to analyze your content. And this is going to say accept the content in the form of a document, and then it is going to render you the tokens. The tokens are then pushed to the index writer, and then the indexes are written inside the directory. Okay? Is that clear, guys? Do you have any confusions over here? Meanwhile, I see that there are a few questions over here. Erpan asked me that does Lucene works on the basis of inverted indexes? Yes, correct, Erpan? Yes. So it works on the inverted indexing only. And I'm going to quickly discuss what exactly is inverted indexing in case, all of us are not aware of what inverted indexes are. So Manish says metrics is easy but tough to maintain. Not really, Manish. I mean, this comes pretty handy when you talk about say the documents which are coming in the form of a stream, and you have indexes which are rendered by the analyzer itself. It would simply go and update the existing metrics. So it is not really tough, I mean, as in how you think. So along with that, okay, Erpan has another question. Can you please show the example of for the control flow? Okay, I will be showing you a few examples as well. Okay, how does analyzer and index writer look like, and where is the directory stored? Yes, okay, I would be taking you through that as well. Rakesh, yes, you can develop your own custom analyzer as well. I'm not sure if this is going to make any sense. I'm just going to give you a little tweak on what exactly do we do in the classes here. So if you look here, we have this, we generally discuss this, very, very explicitly in the classes which we do. So if you look here, these are a few of the Java examples in which we spoke about how you can use that in your code. So the course does not really, talks about what Solr is and how can you, make it work, how can you accommodate it, what are the features and stuff. We give you the practical knowledge as well. So we let you know that how exactly can you use this particular feature, or, the power of the things which are developed and delivered by Solr in your existing application. So we completely guide you through the entire workflow. So I'm not sure. For some reason, I'm not able to pull out the code. Yeah, actually. Right, Erpan, it is actually stuck. So let me take a few slides and we'll come back to this and I'll show you. We have developed a few analyzers. In fact, I gave this as one of the assignments to my classes, that they were actually wanting to use, few features from some analyzer and some other, few other features from some other analyzer. So they asked me that can we use more than one analyzer in the process. So the process goes in such a manner that we can use only one type of, the tokenizer, and we can use multiple filters. So I would be coming up to that in a little while. So this is going to be more clear when we see that in action, basically. So I think everyone is clear about how the flow goes like, right? We have documents, we analyze the content, we create the tokens out of it, and we push the tokens to the index writer. which writes all the tokens to the directory. So directory is nothing but the file system, basically. So if you look here, these are, this is my instance, the Solr instance. So this is another very handy feature which comes with Solr, is that it supports multiple collections or multiple cores on a single instance. So I'm just running a single instance on my machine. However, I can bifurcate or I can separate out the collections on the basis of how exactly, you know, I want it to be. So like I have bifurcated my you know, data in 4 cores: collection 1, collection 2, Edureka, and hotels. So if you would like to see that how data is basically stored, so this is the index files which are generated, which are created by Lucene and Solr. So this is how the data is stored. So I mean, you would have to specify that what all fields goes inside the indexes, what all does not goes inside the indexes. So essentially this is how the indexes would look like. I think that is one of the questions from a few folks out here. Yeah. Okay. So along with that, okay, Nitin says, does analyze take care of stop words? Yes, indeed, Nitin. We in fact, I mean, I'm not sure actually. I should have said a few things out here. If you look here, this is while indexing. So you can use the analyzer. If you look here, I should have actually shown you this in Eclipse. Would have been more clear then. But anyway, while writing the content to the directory, we can analyze the content on the basis of, or the choice of analyzer you want. Likewise for here, we are using the standard analyzer, which has certain features. So I'm not going to go into, you know, depth of what standard analyzer does. We have simple analyzer, we have stop word analyzer, we have porter stemming analyzer. So you have lot of analyzers available with Lucene, okay? And we are going to provide all the examples of using that through code in the real classes. So right now I'm just wanting to give you the idea of how things go about. Yeah, indeed, Raj, this is pretty similar to what happens in Hadoop as well. Okay. Rahul also asked me this question that, hi, if I have to specify what goes inside the indexes, then what does analyzer do? Okay, so I guess I'm not sure, Rahul, if you noticed here, we created a file here, okay, and if you look here, we are creating the indexes here, and we can choose. Okay, let me just quickly. Okay, this is the document and these are the fields. If you look here, these are the few of the fields here. So if you look here, Rahul, we can mention the properties as field store yes or no and index true or false. So we can specify that through code as well and through configurations as well. So I'm not going to go in details about this. So because we have a fixed agenda for this webinar. So I'm not going to divert. I'm not going to actually take you through the details as such. So what I'm wanting to do here is that I'm actually wanting to give you a nice idea of how things go about. So these things are covered basically in the actual course which we run. So we've spoken about how data is indexed in the Lucene. However, at the query time as well, we have analyzers available. So likewise, there is a small example I would like to give you that say I have the school website on and I want to discard if anyone is using any abusive language or abusive text searches on my system. So I'm not actually going to let that search go through on my system, on my application data. In fact, I'm going to just quickly discard that text at the query time itself. So I can make my custom analyzer, which I can use at the time of query. And then I can sort out the data on the basis of the analysis or the kind of subroutine I have provided in my code. So if you look here, we have the query parser over here, which translates your text from the end into the arbitrarily complex query for searching. So the query parser is going to also work on the similar concept of analysis. It is also going to be analyzed through the analyzer, and it is going to break this into the text fragments. Then it is going to create the query object from this, and then it is going to push this query object through the index searcher, which is going to push this query object to the index directory, and it is going to fetch out the results as in how they're required. Okay? Is that clear, guys? Okay, Sujit says, does filtering use indexes or only searches? I think, Sujit, you're talking about the faceting filter which we were talking about, yeah? Am I correct? Yeah. So, yes, it is also going to use the indexes only. In fact, another very, very important thing in Lucene is that if you are, skipping a field, say I have this similar schema I had, and I'm saying that I'm indexing name, I'm indexing brand, I'm indexing price, but I'm not indexing OS and processor. Another thing to take a keynote of here is that if I'm not indexing a particular field, I would not be able to search through that field. So essentially, to support the search feature, that particular field value is supposed to be indexed. Okay? Is that clear, Sujit? Does that answer your question? So, in a way, the filtering which we are applying on the data sets, it essentially has to go through the process of indexing. Again, this is another very, very nice feature which comes handy with the Solr, is that scoring. Scoring is nothing but we are assigning the weightage to few documents in the result set. So I'm sure everyone must have seen the paid ads on Google. So when we are looking for a particular, say, text, we have a few documents which come, as the topmost results in the Google. Have you ever seen that? They're basically the advertisements. Have you ever seen that? Any one of you? Yeah? Yes, no, maybe? Okay. So I guess Sujit has seen it. Okay, Nitin has also seen, Raj has also seen. Yeah, Arpan, right. So e-commerce websites are basically making money out of it by endorsing few brands. So this is in fact the, the sole motto of it, that we are providing a weightage on a particular, say, search keyword. So this can be done on the index time and on the query time as well. So at the time of indexes, creating the indexes, we can always say that field.set boost, and we can boost that particular field. So the boost is basically used because in Solr, let me just take a quick example over here. So maybe this is going to be more clear if we take a quick example over here. So if you look here, I'm saying star.star, which is more like select star from your database or table. So this works in a similar manner. So I have 42 documents which are here, and I have this document which is coming first. So there is a reason this document comes in the first place, is that this document, there is a score which comes along with each document. So it is actually, this particular document is having more score than the rest of the documents, and that is why it is coming first in the search results. So scoring is doing the similar thing. Scoring is helping you have more score. The score of the document is basically boosted. So you can achieve this at the time of indexing and at the time of query as well. So we can do that. So we basically have a few, we have a full, lecture which is dedicated to the scoring in the course. So Lucene allows influencing search result by boosting, by using boosting at the time of indexes and at the time of query as well. So this is going to affect the score of that document, and hence affects the position of that document in the search results. Yeah, I hope the idea is clear. Anyone has got any confusion about this? Okay, Nitin says, what if all are, okay, you mean all the documents are boosted, is what you mean to say. Okay, so Nitin, if all the documents are boosted, or let me say an example in which you have two documents which have the similar score. I think that is going to be more appropriate example. All the documents cannot be boosted as such. So all the documents cannot have all the terms which are there, right? Yeah, okay, so I got a question. So in that case, these two documents are going to appear, I mean, if they're going to have the same score, this is, okay. Hari, I'm not sure, what are you asking? What do you want to make sure? So let me just quickly take up Nitin's question. Okay, again, Hari, if you're trying to push the same document again and again, if you look here, let me just quickly take up this question, Nitin. So if you see here, this is the ID of that document. And if you look here, just to answer your question, you have, I'm just trying to push a document over here and say I have ID 123 and say the title or say name. Name is, my system is very, very slow today. I wonder why. So I'm just trying to submit this document. It went ahead. Okay. However, if I say that the ID of this document is 123, name is Hari, and next time I push the another document which has the ID 123, but the name is Nitin, it is going to go through again. Okay. So if I am looking for something, I say that I'm looking for name as Hari. What do you guys think? Am I going to have any results here? Because the ID was same. Do you think we are going to have any results over here? No. Actually, if you're going to push the same document, it is going to override that same document again and again. However, if you're going to look for Nitin, you're going to find the document with the name Nitin, because that particular document was overwritten. Is the idea clear? It is actually going to override the same document again and again, but the processing is going to be an overkill. So there is no mechanism by which we can. Okay. So let me just quickly cover a few concepts. Okay, I would hold on the questions as of now. Okay, let me just quickly wrap up the presentation, and we can say that we can take a few questions once I complete the designated topics. Is that fine, guys? Because I mean, I do not want to stretch over the time which is assigned for this session. Okay. So, okay. Okay, let me just see. Okay, so this is how my search system would basically look like. Okay, so this is essentially how my search system looks like. All the parts which are highlighted in blue are the part of the Lucene, and rest of the parts are outside the Lucene. Okay, so the first step is going to be obviously the indexing. We have been talking about it. So second step is going to be the analysis. We're going to analyze the document. And then the third step is going to be searching, which is the practical usability of the data which we have indexed. All right. So over here, if you see that there could be many ways in which I could acquire the content. All the content which is acquired from the, say, web or PDF or Word documents or any document repository, I'm going to build a document which my Lucene system understands. So I need to have a document which essentially needs to consist of field and value pairs. Okay. Then I'm going to push this particular document into the subroutine where I'm going to analyze the content of this document. And then I'm going to index the document on the basis of all the tokens which I retrieve out of this analysis. So I hope everyone is clear about this, that my analysis phase is going to give you the tokens. the tokens which are generated on the basis of the subroutine, which is as per the analyzer I'm using. Okay. So then after this, all the indexes, all the tokens, it goes through the indexing procedure and it goes inside the indexes. So this is this red thing is going to be where my indexes are going to be stored. This is similar to the directory indexes which I have just shown you. Okay. So over here, the user is going to be provided a search UI, and it is going to say look or search for a particular field, or say particular document or particular product for that matter. So it is going to analyze this particular query, and it is going to build a query out of this. Then it is going to run this query where? On the indexes, this red indexes. And then these indexes are going to return the results as in per the query which you have provided. Likewise, I just sent a query on my UI saying name is equal to Hari or name is equal to Nitin. So this basically converts the query in the format which the index store can understand. Then it runs the query and it renders the results on the same UI through which the user has fired the query. Okay. So this is how the normal search system works like. Okay. So over here, if you see, indexing is the processing of the original data into highly efficient cross-reference lookup in order to facilitate rapid searching. Okay. Then we are actually analyzing. Search engine does not index text directly, right? We have spoken about it. The text is basically broken into series of individual atomic elements, which are called tokens. So I think I've just explained that. Then we have the procedure of searching, which is the process of consulting the search index and retrieving the documents matching the query which you have given through the UI. And they're sorted or not sorted on the basis of how they are expected or how they're requested from the UI. Okay.